Proposition 14. If two straight lines not lying on the same side make adjacent angles whose sum is equal to two right angles with some straight line at a point on it, then the two straight lines will be straight on with respect to one another. Okay, quite a statement. Let's see what it means. There are two straight lines. Okay, so you have one line and another line, right? So on this, at this point, another line is straight line is there, right? So let's say this is A, this is B, this is C, this is D. Okay, now what this statement says is that if two straight lines, they are not on the same side, so that means they are not parallel to each other or on the one on top of each other. If they are not lying on the same side and they form two angles with another line, then the two straight lines will be straight on with respect to one another. So these two angles are formed. Now if these two angles are equal to two right angles, then this line will be straight. Yes, let's see how we can prove that. Now what we have been given is BC and CD, sorry, BD. BC and BD, two straight lines, another at B, and we are given that angle ABC plus angle DBE is equal to two right angles. This is what we have been given. Now what we have to prove is that angle CBD is equal to two right angles, because if it is two right angles, then it will be a straight line. Or straight on with respect to each other. Okay, let's use proof by contradiction. So let us say BC BD is not straight on to CB. Let's say another line is there, BE, which is straight on to CB. Okay, so we have another line B which is straight on to CB. So that means angle ABC plus angle ABE is equal to two right angles, since AB stands on CBE, which as per our statement assumption, BD is not straight on to CB, is a straight line. Now we are given that angle ABC plus angle ABD equal to two right angles. It is given here. So now we have got ABC plus ABE equal to two right angles, ABC plus ABD equal to two right angles. So if two things are equal to the same thing, then they are equal to each other. So which means angle ABC plus angle ABE is equal to angle ABC plus angle ABD. Using one of the axioms that if there are two things which are equal to each other, if you remove the same quantity from both the sides, then they remain equal. So let's remove minus angle ABC. So this and this gets taken out. So we are left with angle ABE is equal to ABD. ABE is equal to ABD, which is obviously wrong. That means our assumption is wrong. That is, BD is not straight on to CB. So therefore, BD is straight on to BC, or BC is straight on to BD. So basically here there are two things. In some other proposition we had that if on a straight line you have two angles formed, then the sum of the angles are two right angles. Here it is exactly the opposite. If you have two angles, adjacent angles equal to two right angles, then the line on which they are standing is a straight line. So that is proposition 14.